Hi everyone, my name is Kingsley Idoko and I want to welcome you to this section of the video. In this section of the video, we are going to be looking at the implementation of route reflectors for IBGP peering. We're going to look at the design, we're going to look at the various advantages of doing route reflector. You're going to see that for route reflector, it's pretty much easier to implement as compared to the confederations and as well as the full mesh designs. We're also going to see the scalability that is associated with route reflector. You're going to see that in the real world, this is what you typically go to find within the service provider environment. The reason being that for route reflectors, they are pretty much very easy to implement. They are scalable. It reduces operational cost. There is reduced size of the RIB. There's reduced number of BGP updates, and it supports incremental deployment. We're also going to see the caveats that are associated with route reflectors, being that if a route reflector device or the router goes down, then we might lose end-to-end reachability. We might lose prefixes that we previously learned from the previous IBGP pair. The reason is because the route reflectors is what is taking in the prefixes, learning the prefixes from all neighbors, and then in turn breaking the split horizon rule and advertising it back to all every other IGP neighbors within the BGP core. You're going to see that convergence in this case is relatively slow as compared to the full mesh designs. There's reduced path diversity, and also we don't have optimal paths. The reason is because the control plane is being handled by the route reflector, and so it's ultimately the device that is making the forwarding decision. So let's get started. Now, this is my topology that we've been working with. We have router 1 to router 11, where router 5 and 6 are in autonomous system 56. Router 11 is pairing with router 3 to a private AS number, and also router 10 is also pairing with router 4 via an EBGP pairing. So as it currently stands, if I break up my pen, this represents the core. So this represents the core of the BGP network. So this is where we're actually going to be doing or implementing the route reflector design. So in my case, I'm going to be using router 1 and router 2 as the route reflector. So what's going to happen is every router is going to pair, every router within the core are going to pair with the route reflectors. Okay, they are going to pair with the route reflectors. Similarly, they also pair with this route reflector. Okay, they will be learning the update from the route reflector, and they will also be making their forwarding decision based on what is advertised by the route reflectors. We're also going to see that there's also going to be a pairing between the route reflectors because we want a situation whereby they are able to synchronize their information, their BGP table, to ensure that they all have the same information, and that same information is being advertised to the IBGP peers. Also, to the customers, of course, we already have BGP configuration. So in this case, it's going to be an EBGP pair, okay, that we have between the provider edge devices and the customer. So here we already have a private peering. So it's private because we are using autonomous system of 6511. Here we are using an autonomous system of 56. Same thing here because we did say that let's assume that this router 5 and 6 are all from the same customer and they are doing multi-homing to the same provider. Same thing for this part. Here is running autonomous system of 10, and so we are doing transit connectivity to this customer. So that is what we are really going to do. So our first focus now is to do IBGP peering with the route reflectors. We learn all the prefixes from every node within the BGP core, and then we also see that how we can also bring in all the prefixes we are learning from the customers into the full BGP network. Okay, so that's where we'll start now. So let's get started. So I'm just going to clean up this. Bring back my cursor. So I'm using Genesis 3. I've already gone ahead to power up the devices. Router 1 to router 11. If you've been with me all through the videos, I did say that we are using sub interfaces for the routers, and so we're able to create a logical topology that looks exactly what we have here. So I already have security telnet access to the devices. So what we're going to do is to verify what we currently have, and then we'll do the implementation. So on router 1, if I say show run, I say show run pipe section router BGP, shouldn't be slow. So I do currently have some BGP pairings. So you are going to see that I have a pairing with router. So this is a pairing with router 2. Okay, so this is router 6, sorry. So we're actually working with router 1 here. So for router 1, so you can see it here that I do have the BGP process already running, and I have decided to leave uh, in the IBGP pairing that we actually configured in our previous video with the full mesh design. So it's pretty much going to be the same. I don't want to start building the IBGP pairing with router 5. So we're just going to leave this as it is, but you're going to see that currently we don't have any IBGP pairing within the core. So from router 1, same with router 2. So if you look at router 2, so if I say show run pipe section router BGP, uh, sorry, BGP, and I hit enter, you see we only have a pairing with router 6, which is the EBGP pair. So as it is currently, this pairing exists. Okay, so the pairing between the EBGP neighbors currently exists, so that our focus ultimately is going to be within the core of the network. So I'm going to configure a router 1 now to pair with every other devices within the IBGP network. So when we are done, we also move on to router 2. Then before we start looking at the other devices within the BGP core. Okay, so if I go to router 1 now, so router 1 ultimately is going to be pairing with all these neighbors. So I'm just going to minimize this a little. So on router 1, we're going to go back to the BG process. I'm going to say config T. Now, okay, so let's get started. I'm going to say router BGP 1. Okay, now I want to use a template. All right, so there are ways we can actually manage or scale our BGP configurations. We've already seen that with the full mesh design where I use the neighbor group. Now, remember what we did before was that we used the neighbor group, right? Okay, so we say neighbor hyphen group, right? And so we added what we call the BGP attributes, okay, the configuration attribute that were similar, because here under the neighbor group we say, oh, if the remote AS is 1, remote AS is 1, and the update source, and we said if the update source was what, if it's loopback 0. Okay, so this is what we actually did before, and we also said that we also added the specific address family syntaxes, where we also say, okay, for this neighbor that we are activating. Okay, so neighbor group is actually a way of managing BGP configurations. So neighbor group now, in this case, neighbor group is still there, but you're going to find out that neighbor group is not the only options that we can use. We also have other templates. So in terms of the BGP templates, the templates that we can use to manage our BGP configurations, we have the things like the peer session. Okay, so we have peer session. Okay, we also have peer policy. Okay, now for the peer policy, this applies to iOS. All right, so although the neighbor group 2 is there, okay, so we can also say neighbor group. Okay, So the difference between peer sessions and peer policy is this has to do with global information about BGP, while peer policy has to do with AFIs, that is an address family related. So if I want to maybe do route reflector for IPv4, and so I have to go to the address family and say, okay, for IPv4, I'm actually going to apply this peer policy. We are going to see that for neighbor group is a combination of both the peer session attributes and the peer policy parameters. So the both global BGP parameters and the peer policy parameters are all combined into the neighbor group. Personally, I like using the neighbor group because I can just specify the remote AS, I can specify the update source, I can specify the next stop information, I can specify things like if I want to do route reflectors. So for this case, what we are going to be doing is this. Let me just wipe this. So just look at it this way. For templates, okay, for BGP templates that we can actually use to scale or manage BGP configuration, for iOS, you have three options. Okay, so the first one is going to be the peer session, which I just mentioned earlier. I just want to make a difference. But for XRO, you don't call it peer session, call it session group. Okay, so we have session group here. Okay, so everything we specify under the peer session or session group are global to the BGP. So they are not specific to any address family, whether it's VPN v4, whether it's IPv4, whether it's VPN v6 or IPv6. It's just global to the BGP process. But when you start dealing with peer policy, but when you use peer policy or AF group in iOS XR, AF group, okay, this is specific to an address family. Okay, so is either an IPv4 or IPv6 or VPN v4 or VPN v6 or even multicast, right? Then however, for the neighbor group, okay, so this is a mix of both the peer policy and at the same time the peer session. So when you combine this together, you can use the neighbor group. So I just like using neighbor group most times, but in this case, what we are going to be using, we are going to make a separation of these two templates, and we are going to apply it to the BGP process. So for iOS XSRO, I'm going to be using peer sessions and peer policy, but for XRO, I'm going to be using the session group and the AF group. So we are going to be tying it to each of the neighbors, so using what we call inheritance. So whatever we specify in these peer sessions and peer policy automatically gets applied to or gets inherited by any neighbor that we want to form BGP peering with. Okay, so with that information, let's get started. So on this router one, I'm going to create the template now. So the first template I'm going to be creating is going to be for, so I'm going to say router BGP one. I'm going to say, so this is your XRO. So you don't really call it template here. You are going to call it session group. Okay, so if I use my up arrow key, I'm going to give it a name. I'm just going to call it, let's call it IBGP session. Okay, I'm going to use question mark. Then you can start tying in whatever you want to do. So I'm going to hit enter. I'm going to say the remote AS is actually 1 and the update source and the update source is going to be loopback 0. So we're done with that. So same with the AF group. So I'm going to say AF-group. I'm going to give it a name. I'm going to call it IBGP AF. So let's just leave it that way. I'm going to use a name that is much more intuitive. So I'm going to say for the address family IPv4 unicast. Okay, so here I'm going to say I want to add in a parameter that say route reflector clients. So we're going to use this later because this router is going to be acting as a route reflector. All right, so if I just say show configuration now, it's going to show me what we just created. So I created two templates. The first one is the session group. I gave it a name called IBGP session, and also we created an AF group and we call it IBGP AF. Now we could as well create a neighbor group, right? So I can say neighbor dash group and also give it a name, and then tying both my global BGP parameters as well as the address family specific parameters. So I want to use this just for us to see the separation between the global BGP syntax parameters and also the specific address family parameters that we can specify in a BGP process. So with this, what I'm going to do now is I'm going to exit out. We can commit if we want, so we're good. So I'm going to go back to router BGP1. So I'm not going to say for so what do we do now? We're going to say neighbor, okay? We're going to say neighbor. So I think I've already added the address family, which is IPv4, okay? I'm going to come out. I'm going to say for neighbor 172. So this is router 1. We're going to be forming pairing with router 2, router so router 2, router 3, router 4, router 7, 8, and 9. So I'm going to say 172.20. We're going to be pairing on their loopback addresses. So I'm going to say 172.20.2.2. So I'm going to say is a remote. So I don't need to specify the remote AS again because those parameters are already part of the template. I'm going to hit enter. So I'm just going to use the word use. Okay, so I'm going to use, I say I want you to use a peer session. Okay, so I'm going to say section group. So I'm going to call it IBGP. So you can use question mark. It's going to show you what you previously specified there, IBGP session. All right. So similarly, under the address family, which is IPv4 unicast now, we're also going to say want you to use this time is going to be what the AF group, right? So I'm going to say use AF group. So I'm going to just specify the AF group, which is what it created an AF group called. I think I called it. So if I scroll up, so if I scroll up here to what we initially created, we called it what? An IBGP AF. Okay, so I'm going to copy, then I'm going to come here, then I'm going to paste it here. Question mark, I think we're done with that now. All right, so if I exit, if I say show configuration, okay, so this is my BGP process now. So for router BGP, we are pairing with router 2. We're tying in, we're inheriting a configuration that is in the IBGP session template. I'm also going to be inheriting what is in the IBGP EF dash group. So I'm just going to copy this now. Then I'm going to use Notepad to duplicate what we have there. So I'm just going to wipe out what we originally have here. Okay, make sure you wipe out everything. Okay, so I'm just going to grab this now, copy, then I'm going to paste. So for every other routers within our network. So let's widen the notepad. So this is 2.2. So this we're going to make this to be 3.3. We'll make this 4.4. So you're going to see that maybe during the exam, this could actually save us a lot of time rather than just typing them manually on the CLI. Notepad is going to be a very good friend during maybe you're taking the CCIE lab exam. Okay, so what we have now, so we have a pairing with router 2, we have a pairing with router 3, router 4, router 7, 8, and 9. So these all make up our BGP core network. So I'm going to go back to, I'm just going to paste it there. So I'm going to hit commit. Oh my god. So I'm just going to say show run router BGP. I think we're pretty much good with our configuration for to every other neighbor. Remember, this is for the EBGP pairing between router 5 and router 1. So same thing we're going to do for router 2. If you look at the topology, so from router 2, we're also going to be paired with every other neighbor within the topology, router 1, which is already a route reflector. So we're also going to do the same thing there. But remember, for iOS, the template is going to be what? Peer sessions and peer policies. So I'm going to say router BGP1. I cannot call it template. I'm going to say this is going to be peer session. I'm going to give it a name. I'm going to call it IBGP session. Okay, so I'm going to say the remote AS is going to be 1. The update source is going to be loopback 0. So I'm going to come out of the command and create another template for peer policy. So I'm going to call it IBGP policy. Okay, all right. So I'm going to say it's going to be a route client. Okay, so all we now need to do is to tie it to the neighbors. So I'm going to say router BGP. So enable the address family, which is IPv4 unicast. Okay, so for neighbor 172.20.1.1, so we're going to say, yeah, I want it to inherit. So instead of using the keyword you use in iOS, we're going to use the word inherit. I'm going to say, I want you to inherit a peer session, and the name of the peer session is going to be what? IBGP section. So you always have to ensure the name is correct. An easy way is just to copy and paste where we originally created it. So I'm going to hit enter. So I'm going to grab this now, just duplicate it for the other neighbors. You're going to see that's why we say for route reflector the configuration is much more simpler, because you have a lot of parameters that are similar, so it just wants to replicate them. So I'm going to use this for, so we don't need router 2 because we are router 2. So I'm going to go to router 3, router 4, router 7, then router 8, router 9, then we go, right? So I'm going to wipe this out, and I'm just going to grab every configuration we have here and paste it there. Okay, so see that session is already up. We want to turn the other guys off. So I think we're pretty much good. So under the address family too, we need to tie in the policy, right? So under the address family IP4 unicast, so we want to say for neighbor 172.20.1.1. So we're going to say we want to also inherit this time a peer policy. So automatically it tells us here it has to be a peer policy. So I'm just going to grab this. I'm going to right click, copy paste. So we're good. So basically what we need to do here is to just take this, go to our notepad again. Let's put it below. So I'm going to paste it. So I'm just going to add my Y, make sure it's correct. Okay, so I'm just going to keep pasting. I want to grab it again just to be sure we are copying the right thing. Copy, come over here and paste. So I'm just going to paste it all down. So I'm going to say, okay, so router 1, so the next one is going to be 3, router 4, router 5. Oh, we don't need router 5. It's going to be router 7, router 8, and router 9. Okay, so I'm going to take this out. I'm going to delete this. So router 1, so 2 is not there. Similarly, the other part, they are not going to be part of it. So I'm going to just paste this in. All right, so I feel with this we are pretty much good. So if I say show IPBGP summary, so we already have, so now we have a pairing with router 1, which is also a route reflector, and we are learning prefixes from router 1. Okay, so router 2 is the way it is now. If you look at the topology, router 2 is pairing with router 1, and it's taking router 1 as a route reflector client. Okay, so it means everything it has in its own BGP table, I mean its own routing table, is going to advertise it to router 1. Router 1 is going to also be doing the same thing to router 2. It's also going to be assuming that router 2 is also a route reflect a client. So every prefixes that router 1 knows about is going to. So the idea is we are trying to just synchronize their updates, right? Just to ensure they all have the same information in the routing table. And so if any of the nodes you fail, then there should still be reachability because they have the same, there's high availability, and because they ultimately will have the same information in the BGP table. Okay, so if we go back, so we're done with router 1 and router 2. It's pretty much simple. Next now is we want to go to the clients actually. So we'll begin with router 7. So on router 7, if you go there, you're going to see that for router 7, if I say show IBGP, BGP is not active. I say show run pipe section router BGP. So you're going to find out that BGP is not currently enabled on this box. So I'm going to say router BGP 1. We don't need to use any template here because we are just paired with two route reflectors, right? So I'm just going to say for the address family IPv4 unicast. Okay, just enable the address family. So I'm going to say neighbor 172.20.1.1, which is in a remote AS of 1. Remember, IGP is up, ISIS is running, and so we should have transport between router 7 and router 1. So I'm also going to say neighbor 172.20.1.1. Update source is going to be loopback 0. Okay. What we could have also added is we can also go to the address family and say, okay, for this neighbor 172.20.1.1, you can say I want to activate. But you don't really need to do that because by default it's activated. So similarly, we're also going to do the same thing for router 2. We're also going to pair with the route reflector router 2. So I'm also going to say neighbor 172.20.2.2. That's going to be in remote AS of 1, same process. And so it's mechanically up 172.20.2.2. My update source is going to be loopback 0. Another address family IPv4 unicast. Okay, IPv4 unicast. I'm going to say neighbor 172.20.2.2. I want to activate. All right, so we're good with router 7 is good now because we're saying show IPVGP summary. So we now have pairing with those guys. So if I say, so we have pairing with router 1 and router 2, and we are learning prefixes from them. So the reason why we are learning prefixes is because they are route reflectors. So the prefixes they are learning, they are IGP. So if I say show IPBGP, you're going to see that most of these prefixes are their IBGP pairs, which is actually coming from AS56. Next on the line is going to be router 8. So we'll move on to router 8. It's an XRO, so it's an IBGP pairing. So I'm going to say router BGP 1. Go to the global config mode, router BGP 1. I'm going to see I'm going to enable the address family, which is IPv4 unicast. Alright, so I'm going to exit out, and then I'm going to say for neighbor, it's going to be 172.20.1.1. We are going to say is a remote AS of 1, and my update source is going to be my loopback 0. Okay, so we're also enabling it for address only IPv4 unicast. That's pretty much what we need to do here. So something else you can quickly add is, but you have to say BGP log neighbor changes detail, just to us to be able to see the logs. I'm going to hit commit. So if I should come here now and expand it, you are going to see that we are seeing some log messages. One is saying connection has been established for router during this time. For, I guess it should be, so router 1 is up, as you can currently see. So I'm just going to say show run pipe section. Okay, no, just a show run router BGP. So I'm going to just grab this and add the other pairing just to make it a little faster. So just come down, paste. So I'm going to grab this. All right, so make sure you copy it well. Uh, then I'm going to put 2.2. Okay, so I'm going to grab this config and just paste it on all routers that are running XRO. So router 8 is running XRO. Okay, so we're good. You can see show configuration just to verify. So we're good. I'm going to hit commit. So we're also going to go to router 4 because router 4 is also running the XR codes. So we already have pairing with router 10. So as you can see here, we have pairing with router 10 and router 6. They are EBGP, but of course our concern here is for IPv4. So I'm just going to copy and paste. Oh no. So go back to the notepad. I'm going to copy this and paste. Okay, so I'm going to hit the commit. We're not logging BGP messages. We always want to have that BGP. I'm going to say BGP log neighbor changes detail. I'm going to hit commit just for us to see that. So if I say show BGP IPv4 unicast, so that's the table. I want to see the summary. So as it is now, we have pairing IBGP pairing with router 1 and router 2. So we are learning. So we're currently not yet learning prefixes from router 1, but of course we are learning prefixes from router 2. I believe we give it some time, we should start picking up the prefixes from router 1. Okay, so what is left on the topology? So we have enabled router 1, router 2, router 8, and router 4. We also done it for router 7, then it's router 9 and router 3. So an easy way is the configuration is just going to be the same. So we're going to pick router 7. So I'm just going to come here and say show run. I'm going to pipe it and say route BGP. So I'm just going to grab this config. So what we don't need is no, everything here we need it. So just the pairing between the two routers. I'm going to grab this. I'm going to go to router 3 and just paste it there. Config T. I'm going to paste the config there. It's pretty much going to be the same. I'm going to save. So we should see the BGP process coming up. So 2 is up. Show BGP 1 is up. So IPBGP summary. So we are pretty much good with that. Same with router 8, I guess. So for router 8, is it router 8? I mean router 9. I beg your pardon. So router 9. These messages are really because of the memory, overutilization of this my physical laptop. So, but it doesn't stop us from being able to do our configuration. So I'm just going to paste the same. Oh no. So what I'm supposed to paste? Let's grab it from router 3 again. I mean router 7. So I'm just going to grab this now. Go to router 9 and paste. So with this, I guess we'll have full convergence as it is. So we go to the route reflectors. I'm going to say show BGP IPv4 unicast. So these are all the prefixes we are learning from all our pairings. Alright, so some are from your IBGP pairings, some are from your EBGP pairings. So as it currently stands now, all the prefixes we are learning are from the external neighbors, right? Because you're going to see that their AS part is included, right? So we don't really have an IBGP prefixes that we're learning here, and that is because we have not yet really originate the IGP prefixes. So what I want to do now is I'm going to go to each of the router and I'm going to use I'm going to advertise the prefix just using the network statement. All right. So later we're going to look at different ways we can actually originate prefixes, like I earlier said. We could use route map, route policy. We could use redistribute commands. We could use network statements, and also different ways we can actually advertise that. So as it is now, I'm going to go to router 1 and originate that prefix. So, so on router 1, so I'm going to say config t router BGP1 under the address family IPv4 unicast. I'm going to use the network statement, which is going to be 172.20.1.1 slash 32. So I'm going to hit the commit. Okay, so if I say show IP BGP, show BGP IPv4 unicast, regular expression, anything that does not have any autonomous system tied to it. So you're going to see that we are now originating this our own prefix. You're going to see it was locally originated. I have a best part to it because I own the route. So let's do the same thing for router 2. So router 2, I'm going to say router BGP1. We can go to the address family IPv4 unicast, then network. So here is going to be 172.20.2.2 slash 32. Okay, it's different. So we're going to say mask is 205. Excuse me. Okay, so I'm going to hit enter. I'll hit end. So going over to router 3, it's going to be the same thing. On router 3, I'm just going to go to the global config mode. So I'm going to say router BGP 1, address family IPv4 unicast. Then I'm going to use the network statement, which is going to be 172.20.3.3. Max is going to be slash 32 5 5 5 Okay, so same way, say show IPBGP now. You're going to see that we are locally originating the loopback address of router 3. So we'll go to router 7, config T, router BGP1, address family IPv4, unicast. Network statement is going to be 172.20.7.7. The mask is 255.5.5.5. So we're good. Router 8 and router 9 is what we have left. So on router 8, we're going to exit router BGP1, address family IPv4 unicast. My network statement is going to be 172.20.8.8 slash 32, which is much more easier. And the last but not the least is going to be router 9, T, router BGP1, address family IPv4 unicast, and the network statement we are going to use is going to be 172.20. I hope 172 network is going to be 172.20.9.9. The mask is going to be 245.255.245. So with that now, we should be originating all the loopback addresses for the IBGP neighbors. So if I say show IPBGP, so as you can see, we are actually originating those prefixes. So all the way from router 1 to router 9. Some have root failure because we're already learning them through IGP. IGP has a lower administrative distance as compared to the IGP. I don't know if I've mentioned this before, that for your IGP peers, so if I'm pairing IBGP, my autonomous or my administrative distance is by default 200. Okay, but for EBGP peers, your administrative distance is going to be 20. Of course, for your IGP, in this case, you are using ISIS, right? Intermediate system to intermediate system. The administrative distance is going to be 115. All right. So in that case, if I'm learning a prefix from IGP and I'm learning the same prefix from an IBGP pair, IGP is always going to be preferred. So that's why it's telling us here that, oh, we have a rep failure for these prefixes, because it's learning them both from IGP and also learning them from ISIS, which is your IGP. Okay, so but it's saying, oh, there's a rep failure. So if you look at it on the routing table, you see they will not end up in the routing table because they are not the best part. So I'm going to say show IP routes. Okay, so you're going to see that those loopback addresses were linked not from what is it called? Not from so we are currently learning those loopback addresses from your IGP, not from your what's it called? Not from your IBGP neighbors. Okay, so I'm learning them through IGP, I'm learning them through IGP. So IGP is preferred because of my administrative distance, which is what we are seeing here as 115. Something else I want to quickly throw your mind to is I see show IP routes. This is what we are learning. This is what is in the routing table, and this is what will be advertised to our neighbors, right? So the problem now is if I say show, if we look at the BGP table, show IP BGP, this is what we are learning. We are going to find out most of the prefixes that are in the BGP table were not installed in the routing table, right? Especially for our EBGP pairs, they were not installed. Why? Of course, as we earlier talked about in when we did the full mesh design, you see that although these parts are valid, this router does not currently have a best path to this destination. Because if we take one of these router, for example, let's say 172. So on router now, I'm going to say show IP BGP to 172.20.5.5 /32. So currently we are learning it from router 1 and our next stop is router 5. Okay, but router 5 is not currently accessible. Okay, so as it is, bring up my pen, just a sort of a review. Router 5 originated the loopback prefix, advertise it to router 1. The router 1 then go ahead and advertise it to all the route reflector clients, right? Okay, so they have been advertised to all the route reflector clients, including router 2. But the problem is, as is receiving the prefix from router 5 and sending it to all these pair, it does not modify the next stop. Okay, so the next stop is on change. So that creates a problem for all these routers because they don't have reachability to this customer. Okay, but they have reachability to router 1. Okay, you are going to see that when router 1 advertises prefixes to router 5, router 1 is going to set the next stop as itself. That's what BGP does by default. So EBGP, so when there's a pairing between EBGP and another EBGP neighbor, so this is a router, this is another router, and there's a pairing. Whenever this router advertises prefix to this router, it's always going to set the next stop as itself. Okay, so its next stop is going to be self. Same for this router. However, when this router then that is having a pairing with an IBGP neighbor, when it advertises prefix learned from this neighbor all the way down to your IGP, it doesn't modify the next stop. So what we said earlier was that something we can do is to tell these routers. So on router, so So what I'm going to say, tell router 1 that look, whenever you receive prefixes from router 5 and you're advertising it to your IBGP peers, set the next stop as set the next stop to yourself. Okay, so that's one method. Or we can just simply take this interface connected to router 5 and use the redistribute command. Say redistribute connected. So if we use the redistribute connected, that automatically is going to advertise that interface into the BGP process. Or we can also just advertise this interface. This interface is going there into our IGP. So if we advertise into the IGP process, then of course this router should now have reachability to this next stop address of router 5. Okay, so we can also do that. Something else we can also do, we can also say passive interface. So we're going to try it for, so we're also going to say passive interface. Remember what passive interface does? Not so. So it's you receive IGP, you are not processing routing update towards that interface, but you are advertising that interface into the IGP process. Okay, uh, when you go through OSPF and ISIS, you read more about the passive interface. You're going to find out when you apply the passive interface command into an interface, what that tells the router is that it shouldn't send out. Okay, it can, you shouldn't process routing update of that interface. Okay, but you can receive, but you cannot send you can send out, but you cannot receive. I think it should be one of those way, but you can read about it. But you're going to see that once we enable the passive interface on this link, then we also definitely going to advertise it. So here, when we look at what we are going to do here, we are going to set the next stop to self. Here we are going to advertise this interface into IGP. Here we are going to use the redistribute command. Okay, then here let's use what's left now. Let's use passive interface. Okay, so we're going to use the passive interface command just to see how we can get those things to work. So I'm going to clean up everything we have here. Control Shift 2. If I go to router 1 now, so as it currently stands, if I ask router, okay, so let's just do it from router now. I'm going to say show IPBGP for regex. Okay, I'm going to say anything I'm learning from autonomous system 56. So we're learning a lot of prefixes from those customers, but currently we don't have a valid. We have a valid path, but we don't have a best path to those destinations, right? Now, something you also notice is this. These prefixes we are learning, you are going to see that we don't really have path diversity here, right? Because what we are learning, because we are all learning them from the route reflector. But if you go to the route reflector, you are going to see for route reflector it's going to be different, because if I come to the route reflector and say show BGP IPv4 unicast for regex, anything that we are currently learning from autonomous system 56, there's path diversity here, right? But the problem is, when the route reflector receives the prefixes, it's going to perform its own calculation on those routes. Okay, when I say calculation, means it's going to apply its own local policy, right? So once that local policy is being applied, best path are choosing. Because if I tell this router how are you getting to, if I say show IP BGP for 172, so let me just paste it. So I'm going to ask how are you getting to this network? He's saying that he has, okay, here is just having one part, and as it is, that one part is the best part. Is it just one part? No. Okay, so sorry. So it's two parts. He said I have two parts to this destination. Okay, but my best part is one. So what happens is the router, the best part is what will actually be removed. It's not that it's going to be removed, it's going to be moved from the BGP table into the routing table. All right, so in the routing table, so once you get to the routing table, that is what is virtually going to be advertised. So when route reflector receive prefixes from multiple neighbors and it has multiple paths to a destination, by default the router is going to pick one path to that destination, and that one path is what eventually gets advertised to all the route reflector clients. So that's why we see that for if we also ask router, if we also ask router 9, how do you get to this prefix? So I'm going to just grab this, copy this. Let's try it on router 3. I think router 3 should have. So if I paste it here, so router 3.2 is having two paths, but it's saying my best path is number 2. We're going to find out later why all these are this. But let's go back to router 1. Let's quickly do what we're supposed to do here. So I'm going to say router BGP 1. Sorry, so I'm going to say should run router BGP. It's easier this way. So I'm going to go down to this neighbor. Okay, so I'm going to grab this. See, so what I'm going to do now is I'm going to say so what we should do is this. We are going to tie it on the, let's tie it to the template. No, that's not what we need to do. That's not what we need to do. We need to just apply it. We are saying we don't want to force ourselves to be on the data part for every prefix that we advertise, but we're only going to tie it to any prefixes that we learn from our IBGP peers, right? So we're going to tie it to this, uh, because if we should apply it to the global template, it means every prefixes that router 1 learns is going to always set the next up to itself. That means it's going to be forcing itself to be in the data path for all traffic. Later, I'm going to explain to you that for route reflectors, what they are really in control of is the control plane, but the data plane is actually, so just because I'm learning prefixes from router 1, our router 1 is advertising my prefixes to me, it doesn't mean when I want to route to or want to push traffic to to a destination, I always have to go through router 1. For router 1 is only managing the control plane, is not managing the data plane, and also is not in the traffic is not in the data part. I mean, so I'm going to right click. I'm going to say copy paste. So I'm going to paste this. So under the address family for this, I'm just going to say next hop should be safe. So what that means is that whenever I'm peering, whenever I'm receiving prefixes from this neighbor, which is router 5, I always want to set my next hop to myself. So what we need to do now is I think I don't want to lose this other config. So what I should have done is this. I just hope I don't lose them. I'm going to copy this, put it in notepad. Let's just put it here. Then I'm going to say I want my next top. So I'm just going to say next top self. So I'm going to copy this. Just going to say Control Shift A. I'm going to right click. I'm going to go to router 1. Okay, and then paste config T. Let's pick back the configuration now. So next up self. So if I say show configuration, so it should be there. Sorry, so we have it here next up self. So let's go to router 3. Let's see what we're still learning from that neighbor. So I'm going to say show IP BGP for regex, anything that originated from 56. Show IP BGP. So if we should look at it, we're going to see that we have best path to route to this prefix
and our next stop is 5. No, that's not what we want to see. Let's do it from router 4. So if I say, okay, so the last command here was this. So currently we still don't have reachability to that prefix. The next stop is still not being modified. I mean, let's look at this policy again. So I'm saying that when I pair with this neighbor, I want my next stop to be rather to be self. Now let me bring back the topology. Let's just try to break down what we are trying to establish here. So what we're trying to establish is this. We are saying that when we learn prefixes from router 5, so if router 5 exchanges prefixes to router 1, and then router 1 then go ahead and forward it to router 7 and router 2, as well as the other IBGP pairs, we want it to modify the next stop to be self, right? So it means whatever policy we are or changes we are making has to apply in this direction towards the IBGP pairs, right? Not towards router 5, because by default, because these BGP speakers are already eBGP, they are automatically going to set the next stop to their self. So the self that we just created, we applied in this direction. That is obviously wrong. What we should be doing is that the configuration or we should be setting the next stop to self when we're advertising those prefixes to the IBGP pair. So we're going to reverse that. I'm going to clean this, go back. So if we go back to router to the BGP configuration, so I'm just going to go back and say for this I want to remove that command I just placed in because it was wrong. I'm going to hit copy paste. So I'm going to just go back and say no. Alright, so I think what we should do now, I'm going to hit commit to save the config. So what we should be doing is this. I'm going to say show run router BGP. So what we should do is this. We need to create a policy, okay, and that policy we are going to tie it to each of the pairs. So as it goes to router 2, as it goes to router 3, as it goes to router 4, as it goes to router 7, and also as it goes to router 8, we want to say, okay, so this is how it's going to look like. So this is currently router 1, this is router 5, and so there's a pairing, and so let's say this is router 2. So we have IBGP pairing between them. Okay, so what we're going to do now is this. We're going to say as we learn prefixes from router 5 to router 1, okay, and then we now advertise that prefixes to or pass it to router 2, we want to set the next stop to the loopback of what, router 1. So first thing we are going to do is we are going to identify the prefixes on router 5. Yeah, I think we already know that. So on router 5, the prefixes we have includes your 172.20.5.5/32. We also have 172. I think the other one is 116.15.0. It's going to be /24. 24. Similarly, the other prefix is going to be 172.16.35.0/24, which is the interface that is actually connecting router 5 to router 3. So what we're going to do, we're going to say if the prefixes, if these are the prefixes and they are also coming from AS56, okay, so we'll just use this matching statement. So if they're also coming from AS56, then we want to set the next stop. We're going to set the next stop, okay, we're going to set the next stop to be, okay, to be 172.20.1.1. okay, so that's what we'll do. So we are going to create this prefix set. We're going to also create the AS set, and then we're going to say, and we're going to use the AND logic format to say, okay, if the prefixes are this and they are coming from this AS, they want to go ahead and set it to this next stop. So this next stop is that's the information we will now forward to router 2 as well as the other IBGP pairs. So with that in mind, I'm just going to leave this for now. So I'm going to go to router 1. So let me just erase this part. I don't want to clean the prefixes. Let me pick my eraser. Okay, clean this out. Okay, so what we're going to do now is this. I'm going to create a prefix set. Okay, now your prefix set is a little bit different in iOS XR. They are going to call it I'm going to say prefix, I guess it's prefix set. I'm going to say prefix set. Okay, I'm going to give it a name. I'm going to say from router 5, right? I'm going to hit enter. Then I'm going to put the prefix values 172.20.5.5/32. Okay, then I'm going to put a comma. Then I'm going to say 172.16.15.0/24. I'm going to use a comma. I'm going to use 172.16.35.0/24. I'm going to say end set. So this is how you create prefix list or prefix set. So in iOS it's called prefix list, but in iOS XR or your AXR 9Ks is called a prefix set. So something else we are also going to check is the AS path. So I'm also going to say AS path set. Okay, I'm also going to say from arrow5 AS. All right, so I'm going to say if the regular expression is originating from 56. Okay, I'm also going to end it with quote. Then I'm just going to use the end set. We can verify it by saying do show run prefix set. Okay, you can just specify the prefix set you created, or you hit enter. Prefix set, specify the name. So we have not yet committed, so it's not yet in memory, but if you say show configuration, it's going to show us what we just created. So I'm just going to hit commit. So if I now say do show run prefix set, we should now see so I'm going to say from router 5, so it's there. These are ways you can verify if your prefix set or your AS set is there. So I'm also going to say do show run AS set path set, I mean. So I'm going to say from router 5 AS. So that's what we have there. So we're going to create a route policy now. So we're going to take these two components that we created, or parameters. We're going to tie it into a route policy, and then we apply it outbound to all the IBGP pairs. All right, so I'm going to say route policy. I'm going to say route dash policy. I'm going to say to all. Let's say to all IBGPs. Okay, to all IBGPs. I'm going to say if destination, okay, if the destination is in prefix set, so if destination is in, if I use question mark, okay, so you don't need to specify the prefix set, just specify the name. So if destination is in prefix set and the AS path information is in, so our AS path information is what now? From, so if you use question marks, you'll be able to see it there. So we're going to say if it's in from AS router 5 arrow 5 AS, then we're going to say then, okay, then we're going to say then I want to set the next hop to self. So we can use self, but you know that for XROs, when you say self, the question now is which IP is it going to be using as is to represent itself. We know the router ID is 172.20.5 1.1, or that our peerings are always sourced from the loopback, but we do need to specify it here to say this is the IP I want you to use to set the next up to, which is going to be 20.1.1. If you say self, it's going to generate an error, so it's better we use this. I'm going to hit enter. then I'm going to say I want to pass the traffic. So I'm going to end the policy, then end my policy, show configuration. That's a policy. Then I'm going to hit commit. All right, so what we just need to do now is to say show run router BGP. Okay, so I'm going to say show run router BGP. I'm just going to grab everything here to all the IBGP pairs. Okay, so I'm going to grab it, I'm going to put it on notepad. Okay, so I'm going to, so we don't need this anymore, so I'm going to just copy the route policy, which is this. Then I'm going to paste it as we pair to all the neighbors. So as we pair to 2, I want to use this route policy outbound. Okay, so let's grab this. So as we go to router 32, we apply it outbound. As we go to router 4, we're going to apply it outbound. As we go to router 7, so we're going to apply it outbound. As we go to router 8, we apply it outbound. And also as we go to router 9, we're going to apply it outbound. So I'm going to copy it now and repaste it on the CLI. I'm going to hit copy, then I'm going to use config T, then I'm going to paste it there now. Okay, so we should be good now. I'm going to hit commit. Okay, so if you can clear out, you can do hard reset. I'm going to say clear IPBGP star. Don't do this in production. Now we don't get log messages, so let's enable log message. I'm going to say router BGP1, then BGP log changes, neighbor changes details. Okay, hit commit. So if I say clear IPBGP star now, we should get log messages. If we still don't get log messages, it's obviously because we are not logging to the console. So login console at level informational. So I'm going to hit commit, or we could say notifications. Okay, so now we are getting those adjacency logs. So if we now say show IPBGP BGP, so we already have best part of those connections, right? So let's filter it with a regular expression, regex show BGP IPv4 unicast, regex. I'm going to say anything that originated from preface 56. We've been using this syntax for a long time. So currently we now have best paths to this destination, so I know how to get to this point-to-point network. I have a best valid path to it. What is most important is the loop back behind the router 5. So we have best path. So this is what is definitely going to be advertised to our neighbors. For example, if I say show BGP IPv4 unicast for neighbor 172.20.4.4, I want to say advertise routes. You're going to see yes, that we're actually advertising these prefixes to that neighbor. Okay, so we're advertising them because we now have a best path to them, right? So we already have a best path and it's been advertised, but I think let's look at it from rather 4 now. So previously this is what we had. We never had any best path to those destinations, but if we use the up arrow key now, you can now see that we now have a valid path or a best path to those destinations. So if I say show BGP IPv4 unicast for 172.16.15.0/24, let's do it for the loopback 20.5.5/32. so it's saying that it has 2 paths to that destination. The best part is part number 1. It's coming from autonomous system 56. So if we try to figure out why it's choosing that part as the best part, we're going to find out that so here is learning it from router 1, which is itself, and the next up is itself, which is router 1. If you look at the weight value is not set. It means they are both 0. If you look at the local preference values are the same. If you look at the origin, the look if it was locally originated, no, in this case it was not locally originated, because you don't see the the string or the word local here. So we are both learning it from, so here we are learning from router 2, which is the route reflector, and here we are learning it from router 1, but we are not locally originating it. If it was locally originated, then you see the 0.00 value here. So the next one is the AS path. So the AS path length is the same here. The origin code is IGP, so it's the same. The next one is, they are both internal, EBGP over IBGP. I think the difference now, so the next up, what do you call it, the metric to the next stop is the same, it's 4040. They are both internal. So when you really drill down, you see obviously this will be I don't know, maybe is the tiebreaker or something, that's maybe the oldest route, or maybe the one that has the lowest cluster ID, which in this case I think, so you are seeing the cluster list here, right? So cluster list here is 172.20.2.2. Although it's not specified for router 1, router 1 has a router ID of 172.20.1.1 probably. Okay, now also look at the originator here. It's saying the originator is router 1. Okay, but here, so even if router 2 is reflecting that route back to router 1, it was actually learning it from router 1. Obviously that would be one of the reasons why it's preferring router 1 as the best path to that destination. But the most important thing we are trying to identify from here is that when you learn prefixes from your EBGP to an IBGP pair, the next stop is not being modified. So what we just did was that we created a route policy to say, when you learn these prefixes from router 5, I want you to send the next stop to the loopback IP of router 1. And so long the IBGP pair can do route recursions to that loopback, they should be able to obviously get to the destination. Because if I go to router 4 and I say show IP self, I think it's just show self, so self for 172.20.5.5/32. You see we have our next stop is router 1, which is the loopback of router 1. Okay, so what we need to do now, we need to so what we did here now was that let me bring up my pen, was that we used the route policy, right? So we use the route policy to match, to say when you learn these prefixes from router 5, then as you are forwarding it to your IBGP pair, please set the next stop to the loopback, right? So that is what we use there. Now coming here, what we are going to use is, we are just going to advertise this interface into the IGP process. You are going to see when you do that, automatically your IBGP pairs will now be able to perform route recursion to that interface, or to the prefixes that is being advertised by router 11. So here we are going to use IGP. Here we are going to use what should we use here now? So here I earlier said that we use passive, so we are going to use the passive command to advertise this interface into the IGP process. Here we'll use what do we use here? Okay, so we can as well use a route policy or a route map. Okay, we can do redistribution here, but I want us to okay, so we did route policy here, right? So here I'm going to do redistribution. Okay, so I'm going to redistribute the interface into the IBGP process. Here we are going to use route map. Okay, now you're already familiar with route map, so we're going to say route map, this prefix, we're going to match the AS number, then we're going to say the next stop as it's being advertised to the IBGP pairs. Okay, so you might be wondering, why did we specifically specify the prefixes we want to match in this route policy? Because in the real world, you know that these are your route reflectors, okay, RRO, so let's this RR2, this RR1, they are not necessarily in the data plane, right? What they are really controlling is so in the control plane, in the data plane they are not there, but in the control plane they are helping you to learn your prefixes. So they bring in the global, they learn about the global BGP table, and then they advertise that those prefixes to all the IBGP peers, right? Even sometimes to the customers. All right. So they are they manage the control plane, but they don't necessarily need to be in part of the data plane. We are going to demonstrate this in the next video, where you see that for the route reflectors, what they control is the control plane, and of course not the data plane. But of course there are ways we can force it to be in part of the data plane, but of course in the real world you don't want to do that, because most times these routers are not really, they are not really as powerful or have the memory required to do that. Okay, we'll talk about that more in the next video. Thank you very much. I see you in the next video.